Cats really like specific plants, such as catnip and silvervine. They show a characteristic response comprising licking and chewing the plants, face and head rubbing against the plants, and rolling over on the plants. Catnip and silvervine are completely different species, but these plants produce cat attractants that have very similar chemical structures known as erioids. Nepetalactone in catnip and nepetalactol and other erioids in silvervine. The research team previously found that this feline response contributes to the chemical defense against pest mosquitoes. Cat attractants also have mosquito repellent activity. Rubbing and rolling allows cats to transfer plant erioids to their fur, which repels mosquitoes. However, why cats lick and chew these plants remained a mystery. The research team studied the behavioral significance of leaf licking and chewing in cats. Silvervine leaves crumpled and torn by feline licking and chewing appeared to have a much stronger aromatic odor compared with intact leaves. The researchers first tested whether leaf damage promotes the emission of erioids from silvervine. Physical damage of silvervine by cats promoted the immediate emission of total erioids. Leaf damage also changed the composition of erioids in silvervine. Nepetalactol accounts for over 90% of total erioids in intact leaves, but this drops to about 45% in damaged leaves as other erioids greatly increase. To examine whether these erioids changes in damaged silvervine influence the feline response, the researchers prepared synthetic erioid cocktails corresponding to the ratios found in intact versus damaged leaves, and presented these simultaneously to a set of cats. The damaged silvervine cocktail promoted a much more prolonged response.
It was easy to speculate that the duration of the response would increase with the amount of erioid. However, it was surprising that the change in erioid composition also greatly increased the feline response. A more extended duration of the response allows the cat to transfer more mosquito repellent to the fur. We can say that licking and chewing contribute to chemical pest defense in cats.
Next, the research team asked whether leaf damage has effects on the amount and composition of erioids in catnip. In catnip, leaf damage increased airborne emission of nepetalactone, but did not alter the composition of erioids. Both intact and damaged leaf extracts contained almost only nepetalactone. The researchers also found that total erioid levels were 40 times higher in damaged catnip compared to damaged silvervine. However, cats showed a comparable duration of the response to 0.4 milligrams of damaged catnip cocktail and 0.01 milligrams of damaged silvervine cocktail, which corresponded to 100 milligrams of damaged catnip and silvervines respectively. This is because the damaged silvervine cocktail had a more potent bioactivity than the same amount of damaged catnip. This was not the case when the damaged silvervine cocktail was modified by replacing the main silvervine erioid nepetalactol with catnip nepetalactone.
We found that the combination of nepetalactol with other erioids is important to induce a prolonged response. The olfactory sensitivity in cats has been optimized to both erioid amounts and compositions of two different plants.
Finally, the researchers compared mosquito repellencies of the cocktails. 10 minutes after introduction of test stimuli, only the damaged silvervine cocktail repelled mosquitoes significantly. Mosquitoes finally avoided all stimuli 20 minutes after introduction. These indicate that the diversification of erioids in damaged silvervine leaves is more repellent to mosquitoes at low concentration. In conclusion, feline licking and chewing damages silvervine, which emits a low level of iridoid mixtures. Damaged catnip emits a high level of nepentolactone. These changes extend the duration of the feline response to these plants, which results in enhancing the chemical pest defense in cats.